Here we have an Asus 4090 that came in for repair. And it looks like we have a missing 4090 connector. The customer attempted to replace the connector and he thought it was a walk in the park. And look at this Hiroshima that we have here. People do not understand that it takes an extreme amount of heat and skills to replace this connector. It may look like a 16-pin connector, but it's difficult to replace. The reason is the board is very thick, and heat alone is not going to remove that connector. It's a multiple step process to do it safely without knocking components off. The board is going to absorb a lot of heat. It doesn't matter how much heat you push onto that board. The board is going to absorb all that heat because it's a 12 to 15 layer board. And the only time solder is going to melt here is when the board itself reaches the melting temperature of solder. This should be empty by default. I do not see missing components here, and that's good. This one is a little bit crooked, but it's making a connection, so it should be good. And it doesn't appear that we have anything missing here. Those are empty by default, as I recall. Flip the board. And we have a bridge here that we need. Oh, that's nothing. Just a tiny bit of a solder blob stuck between those two components. We're going to have to clean this. We're going to have to remove the pins from the holes one by one. It's not going to be easy, but let's do it. That's what we've been doing lately, fixing Hiroshimas. Right now, the first thing I want to do is preheat the board. This looks like low melt solder, but maybe low melt solder was not used properly on this board. There's a proper way to use low melt solder. You see how solder is still soft? That's low melt. Let me go over the steps. Number one, we need to preheat the board, and we're gonna preheat this area. I do not need to put it on a preheater, even though we have one, but there's no reason to preheat the whole board. I'm just going to apply heat on this area. And then we're gonna apply low melt solder and make sure that low melt mixes properly with unleaded. You do not just apply low melt on the surface. The soldering iron must be hot enough. Not hot enough, it should be up to the max. And the tip should be touching the pin and the pad when applying low melt solder, so low melt can make its way all the way in. Otherwise, low melt is going to be useless. You could have a top quality tennis racket, but if you do not know how to play tennis, it doesn't matter. Or you could have a great soccer ball, not the cheap one, like a good quality soccer ball, and it's not going to make you a good player. Just an example. You could have the best billiards pool table and the best stick, but still, if you do not know how to use it, it's useless. Now that we preheated the board, I'm going to apply Flux and We're gonna apply low melt solder. You can see all the heat I applied. Solder did not even flinch on that board. It did not even move. We're gonna soak the pins with low melt solder. All right, now we're gonna attempt to apply hot air and remove the pins, even though I can barely grab pins on the board. Flip the board. I just push the pins down so it's easier to work with. And look at that piece of connector left on the board. That's pin number 1, pin number 2, and looks like pin number 3 wanna play games, and pin number 4 wanna play games. Or maybe it's just me. I'm not able to grab those pins. Why blame it on the pins? All right, so now what we're gonna do is use the NF dot sucker to suck solder off the holes. And I cannot put the NF sucker vertically under the microscope, so we're gonna have to do it off camera. Keep applying hot air, and we're gonna go over the holes one by one. Hole number 1 is good. Number 2. So I have 8 holes clean, 8 strokes, 8 holes. Okay, see? Let's do the rest. NF sucker is magic. I always mention it. It's magic. Very powerful suction. And it gets the job done quicker than anything else in the market. And what do we have? Look at this. The holes are clean, except for this one here. I think we still have a pin stuck. Yeah, it's gone. Done. Tell me the NF dot sucker is not amazing. Tell me that low melt is not amazing. Tell me that I am not amazing. We are all amazing in our own ways. That's why every human being is unique and has features like no other. We are all special in our own ways. And that's why you should always aim at being original and not a copy. Do your own thing. So I have a new connector here. And the connector is in right here. And all we have to do is solder all 16 legs and we should be good. Actually, not 16 legs, it's gonna be 18 legs. We have 6, 6, 4, and then you have the 2 anchor points. We are done. We're gonna use Amtech wipes to clean flux off the board, the NorthridgeFix brush, and 99% isopropyl. You can purchase Amtech wipes and the brush off our site along with all the tools that we use on our bench here. We carry and sell everything. All tools from soldering station, hot air station, the solder sucker, Amtech wipes, the brush, original Amtech Flux, braid wick, power supplies, voltage injection tool, thermal cameras, everything. Just log into NorthridgeFix.com, click on shop, add to cart, check out, pay, and we almost always ship out same day. Right, and we are done. So I have the power cable plugged in, 3 12-volt inputs via the 12 VHPWR connector for Asus, and we're gonna plug the card in the PCIe slot, power it on, and just make sure that the card is functioning. This board came in for a connector replacement, so we replace the connector and we test, make sure we have an output. And we're gonna monitor the screen and see if we got a Dell logo. Yes, we're all good. The adapter is connecting to a Dell motherboard, and that's why we see a Dell logo. The card is not Dell, it's the motherboard. All right, we are done. I hope you enjoyed the video. Let me know what you think, leave it down in the comments. Don't forget to like and subscribe, and we'll do something else in the next video.